Hello, everyone. We are the Amazon Robotics Team 18775, working on the project Common Assembly Line Concept for Robotic End-of-Arm Tooling. My name is Matt, and this is Jack, Hannah, Shreya, and Brendan. We are proud to present our project in collaboration with Amazon Robotics, our client, to create a conceptual consolidated assembly line for various end-of-arm tooling components for robot usage in operational environments.
Our project required a site visit to Westborough, Massachusetts. After networking with our client, we determined several key objectives for our project: to assess the manufacturing of robotic arms, to create and validate an efficient manufacturing line that can manufacture multiple end-of-arm tooling, to establish processes that are faster and more safe than the current state, and finally, to propose multiple process options that will support our client's next generation of robotic subassemblies. Our project will present a low-cost assessment of the current state of production and how to best consolidate the manufacturing of multiple units on a singular assembly line.
We validated our initial process flow assumptions by conducting time trials in RIT's Toyota lab. The setup for our trials is shown on the right. We aim to determine the percentage of time savings achieved by using an automated torque wrench compared to a manual one. A video demonstrating one of the automated trials is provided on the right, and the manual trials are shown on the left. Incorporating our findings into our process flow led to one of the final iterations of our simulations. We assessed financial savings by considering parameters for overhead costs, material cost, and employment and human resources. We found the 60% time savings in automation that was found in the last slide translated to roughly 25% composite financial savings when adding up all of these costs. Based on the volume and size of the product, we could have a 1 to 3 year break even for any investment to establish this new line. With all of the work that we've done for a project, the several challenges in creating our assumptions and validating the data led to a couple successes. First, we have our final simulation completed for all 3 EOTs for both the semi-automation and manual stations, and we have completed the documentation for each of the steps, including our process flow, financial evaluation, and further recommendation for the consolidated assembly line.
Here are the current state simulations of the Amazon Robotics facility for assembling products A through C. The boxes represent workstations, and the triangles on the left represent subassemblies, labeled as WIP to represent work in progress. Current state tasks run in parallel with no singular direction, and no new subassemblies are made until they are used in the final assembly.
Here's the final visual representation of our single line assembly line with semi-automation. And the final iteration of our simulation incorporates a method to track material replenishment/depletion, quality inspection checkpoints at various stations to ensure quality products, updated torque times to provide more realistic data, and improved level loading. Technician utilization rates have greatly improved throughout these simulation changes.
So thank you so much for taking the time to learn more about our team and our project. We're excited to meet you and hope you can stop by our table at the Toyota lab to learn even more about the robotic manufacturing and assembly lines. We would like to give thanks to our corporate sponsor, Amazon Robotics, our faculty guide, Dr. John Bonzo, and the rest of the MSD and industrial engineering staff and faculty for their support.